not very sure whether they complete something or not. Quite a lot of students, about 200 participants on the IBS from all over university. This is under project KPT project, dan Kementerian Pendidikan Tinggi project, where they get about 200 students from all university to study on the IBS. It's organized by a contractor, in fact, contractor. So I got on paper there, first paper is preparation. Before that, I was not feeling well for about 5 days, so ada interruption kat situ. Everything a bit haywire, tak apalah, alhamdulillah. Sekarang dah okay. So we continue with our topic number 4. Kita agak adjust mungkin we find some time to fit in the 2 missing lectures tu, insyaAllah boleh. Okay, lecture 4 basically on application of steel in building construction. This particular topic we're talking about column and beam. Everybody knows about column and beam kan, and then we will go to tengok what those kind of column and beam that is constructed by using material steel. There are 2 different contact together. We're talking, but concrete is a bit different, timber line and steel line. Okay, let's see what we have gone through. This is last semester, that's our regular. So today is supposed to be 14, maybe 21. Okay, tak apa these 2. Okay, alright, let's go to the first one. I show. Okay, before we look into the detail of what is column and beams, let's look at the way this component actually appear in a building and what category or what are the area that they have been placed, or the term that being used here. So in a building, we always have these 2 kind of what they call the structure. One is under the ground, underground, underground. The other one is above ground. Whatever is being built above the ground, we call it whatever is being built below the ground, we call it substructure. You can see the diagram there, whatever those within the area of a brown color zone is called it substructure, which include foundation. And foundation include the footing, piling, whatever foundation. Foundation will stop where they reach the bedrock, then we stop. That's one type of foundation. Okay, the substructure, what I have mentioned here, the purpose of structure is of building is to transfer the load of superstructure to the soil that is underneath, or the load beban from the superstructure has been transferred through the piles to the bedrock. Okay, now this is why the substructure is right against the soil that support it. Okay, now it is important that you spend time working with structural engineers to ensure that all support beam, column, foundation are incorporated properly to ensure that nothing will collapse within the substructure. Substructure is something which happen below. I pernah tengok with some of the videos that shows the failure of the substructure where they got to demolish the whole building. Nanti ada masa kita test failure of building failure on steel structure ni, we capture mungkin some of the videos that is they spend hundreds of million and they got to demolish because failure of the substructure. Mungkin there's not enough study or analysis done on the soil structure. So that is a problem. It causes a lot of problem. Okay, got to demolish. Banyak kat China, even kat US. Okay, what is superstructure? Superstructure is anything above the ground. Of course, kalau you're talking about a house, it's a very simple kind of structure kan, just a single double story house or superstructure. The other one is mungkin pile footing, mungkin you have maybe a bit of piling, bakau pile or concrete pile, just a small. In this case, for a building of high-rise building, that is very clearly shown here, like because why? Because of the superstructure tu macam mega structure, very high or big scale kind of structure above the ground because superstructure. So it is a building where people spend more time. They sit, they study, they live, they work in the superstructure area. The office they work lah. Kalau hotel, apartment, so they spend. There is a habitable area. Spend their time with family and they sleep there. Okay, so this area include the first and second floor inside of a home of any number of floors in larger building. Okay, superstructure basically includes all those above the ground, which are included of beam, column, finishes, windows, doors, roof, floors, and anything else that is above the ground that form part of the building. So that is called superstructure. And bring skip pasal kita nak focus pada column beam kan, basically that's the main structure of the superstructure, right? So before that kita study sikit apa dia panggil load pass lah, what is meant by load pass. Melayu kata laluan beban bebanan. Basically kalau tengok this simple one, the diagram on the right, on the left bottom is load pass. Okay, whatever load from the beam transfer direct to the column, direct to the column and to the foundation. Sorry for the other bigger images. Beam here they call it girders. In America they call it girders. Kalau kat Malaysia or the Asian country call it beam. Steel beam, dia panggil steel girders. Ada juga for timber structure sama juga. Sometimes they call it timber girders. Tapi rated more for beam, for steel. And you got footing. All these frame that you see above the ground will be transferred to the this may be a file cap and then to the ground. That's how the load been transferred. Okay, tengok lagi in another aspect of the issue. So you see this simple diagrammatic to show you how the actually load been transferred to the foundation. So the pass is the load travel through the structural frame. When you see that from the roof, goes to the roof frame, roof trusses, and transfer to the column, and then to the floor, or the floor load will transfer to the column. You see the arrow is going out to the column, and right to the what they call this, the foundation. And then of course they got to prepare for the uplift, whatever. HVAC, the heat, ventilation, and air condition. Whatever equipment inside the roof, above the roof, whatever it is. So whatever load, whether dead or live load, all been transferred to the column. So tracing or chasing of the load. This is the arrow shows that chasing of the load macam dia transferring the flow. Kalau blood, you're talking blood system, your blood system or flow like this goes down bawah. Okay, each structural element must be designed for all loads that pass through it. Okay, so my engineer is being trained in such a way that they have to work out the kind of the sizes of the column, the beam, and whatever details is included in these two structures or two frame, so that it can take whatever load has been imposed on the building. This is extra circuit because here we're talking about a more detailed one. There are a lot of forces that are being included here. One is the wind forces, got the uplift force. The strong wind, the roof can be uplifted. Any area or the external forces, the wind and the lateral load can be imposed on the roof. And then kalau I show you the sway concept of rigid structure, the bracing, and then it becomes stable. This is the green ni pun external load juga, wind. The green is all the wind. Live loads from the building, inside the building. Anything is the moving type building, whether it's furniture, human being, whatever content inside the building is called a live load. And then dead load is the whole building structure dead load. Transfer to the ground. But of course, if you are building in a sub-basement kind of thing, sub-basement means that your lower floor is partly submerged ataupun is designed inside the ground. And it is a retaining wall here. So there is also a ground forces from the side and so from the ground. Kalau ground forces from below itu is more on water level. Kalau water level increase, kalau your design dan take that, then the building can be lift up. I bagi satu contoh dulu, I pernah buat patrol station dekat Dungun. Dungun Kamaman, Petronas patrol station. Then we buried the tank. Tank ni untuk fuel tank lah. Underground kan, fuel tank underground kan. Kalau you tengok kadang-kadang do servicing of apa tu the refill or the petrol or the diesel kan. Ada lori besar kan, so masuk pump dalam underground. So pump underground. So because of the uplift forces so strong, the tank actually submerged underground. Submerged underground. Tapi the uplift forces so strong, happen that ada flood, including water pressure. So the tank was pushed up and then floating kat ground. Walaupun tank tu dia punya foundation dah ada pile semua kan, ikat dengan piling punya frame very nice juga. Tapi pasal apa? Because the tank is empty. Jadi buoyancy lah kalau empty. Kalau tank tu penuh dengan minyak, okey, tak masalah. Itu satu pengalaman saya lah dekat tu. But actually the contractor got to redo the whole thing. Okay, this is another example of the forces. on one of this building. Dia nampak interesting juga, bukan dia only pakai 2 column ya, tapi dia pakai curtain wall and it's something like a canoe kind of design that is Tokyo International Forum. Concept dia basically, I mean the building basically made of steel structures. Ada 2 column ujung ni, and then of course there are a lot of steel frame. Atas ni macam a structure lah, structure macam something like a frame of a ship lah. So dia punya forces interesting juga. Ini dia punya some what you call this detail on the element. Dia kata there is a profusion of steel structure kat sini, and then semi-circular steel girders, ni girders panggil girders suspended from the ceiling, mimic of wooden frame of a ship. Ni macam kapal lah. Gambar kecil ke bawah ni kan Tokyo Forum tu dan kapal je kan. Ni features masuklah dia punya glazing, finish, big inner space, semua kan, okay, detail dia. And ni rib pada roof, tapi roof dia flat kat atas glass. Ni self-supporting curtain wall, ni on their own lah, dia tak support mana-mana And then steel pylon, ni punya pylon is the column lah, 2 column besar ni. Let's see how dia punya load forces. Ni semua kita cerita sikit pasal the function of the load. Okay, kalau talking about section of the building tadi tu, this is dia punya floating beam tadi, yang kata timber frame like a ship tadi tu. Dia kata this thin section of a curved plate, girder center indicate there is no much of a moment here, tak ada load pun kosong. Satu, kalau tengok arrow tadi, ada, remember about you're talking about lateral load is from the wind blue tu, ni roof load, tension, compression semua kat sini. Semua dekat hinges ni je. Dia turn back into the frame, down to the ground. Ni tension rod dia, ni compression rod. Ni kalau ni column ni macam the whole thing ni macam column, ni frame. Tapi tak buat, it doesn't design such way that the column that we used to imagine macam solid column. This is like a frame column, like a beam transfer to column. Ni resisting dan merah, resisting forces, and ni load the building biru. So tension rod kat dua-dua ni, both side ni, keep the pressure on the compression members to create a self-standing curtain wall. Cakap the self-standing curtain wall ni maksudnya this whole thing itself is a frame wall. It acts as a wall as well as a column. So ni, the actual column ada 2 ya kat ujung sana. This is one idea, the way that we identify the forces lah. Kat atas ni pula you tengok moment couple occurs at the rigid connection between the tube structure and the short span structures. This is the structures, so banyak moment yang berlaku sini, the pressure banyak kat sini. Ni the tube structure carries the weight of the entire roof to supporting column. So this is the whole roof ni being at satu big tube structure sini. Ni innovation in structure design lah. Memang is beyond the normal kind of beam and column. Tapi I was trying to show you some of the load forces that happen to this kind of building, which is not so much what we are talking about, the I-beam of beam and column there, but it's more like a innovation to the design without much column there, in which in this case all the elements play a role to support the building. This is another idea of how load been transported or transmitted to the ground. Kita tengok this big cantilever, kita ada cerita pasal cantilever beam nanti, cantilever. Cantilever maksudnya there is no column, no column. Is supported at one point. This cantilever, cantilever beam, roof beam, it cantilever. Okay, C is compression. Kita belajar the few last 2 weeks, 3 weeks kan. T is the tension. That's how it works. This is wind forces coming from there. Kita just the principle, whatever detail tu engineer will work out. Sometimes you look like this roof cannot be supported by itself, tapi with some design feature that taking consideration of this so-called forces, the compression and what they call it, tension, and then this can be done such a way that it looks like it's floating, supported by this cable structure. So all the frame that axial load through all this cable will be transmitted through the other lower portion of the building. Mungkin this is the column to the ground. Ini can be complicated, tapi it's no problem, can be done. Okay, now we go to the topic our beam and column. So what's the difference between steel beam and column? I think you all know kan, steel beam kan. You seen every day, tak tahu whether you observe or not kan. You seen it most of the time. Even in your house pun ada those rumah yang ada steel, sorry, yang ada that has this concrete frame, the column and the concrete beam. Those horizontal is called it beam. The other one is vertical, is column. So what we discuss here is that a beam is a horizontal structure element which withstand vertical load, whereas column basically the vertical element. Anything that's vertical is called column. We span from the substructure to superstructure and play a crucial role in transferring the load from top of the structure to the bottom footing. So kita banyak repeat ni, banyak kali repeat, faham lah kan. Transfer ke gambar bawah ni pun, tengok beam start be fit together. Or the from beam, kalau the floor nanti, or transfer to the column, to the nearest column. So that play a role in term of the distance of the column, the grid point, kan. How do you want to size out all this column spacing? Kalau small column spacing or shorter column spacing, the members can be smaller. They can be smaller. Kalau it's a long span means it's more than 300 feet of 300 meters. Sorry, to 30 meters, 100 feet, then the member will be longer. Kalau it depends on the span of structure. Okay, beam basically is such an element that stand against the bending. Bending, bending kan, bending means when you have the load imposed on the beam, there is certain amount of bending. Tapi everything be taken care because of the sizes lah. Design, you have to design those kind of loading into incorporate where all this I-beam. You see, beam can be in many ways, from a simple raw material that you see on the bottom left here, which is I-beam, I-beam, and then to the composition of connection of column and beam, and then to the big structures like the bridges, even highway. Highway kalau tengok ada some highway tu, the kind of structure bukan dia pakai concrete girders atau concrete beam, dia pakai this steel beam. If you look at all the rebat columns, they will give you the strength. Kalau ada plate ini lagi bagi strength pada the whole column, the whole beam. Look at the intricacy, the detail of the jointing. There's so many members being joined together, but the way we join, they jointed. Ini pakai gasket, Ini gasket, nampak sini is gasket plate. They will hold all this so-called frame, diagonal frame, vertical column to the gasket. So lagi kuat lah ya. This is some of the detail. But kita jointing kita tak detail sangat this time. Kita akan detail when it come topic on jointing nanti ya. This is a cross section of a structural beam. The most common one is yang W lah, flange straight ni. The I-beam, all about I-beam 1, 2. This C channel pun can be used as structure juga, tapi common boleh for small building. Tapi yang the I-beam tu is used for building. Bottom here, all this section pipe channel, they call it hollow section, pun can be used as structure. Nanti kita show some detail in the lecture, and sorry, the slide yang akan datang. This basically cross section on plan. You cut plan to show all this kind of section of column. But we, in our case, atas tu just basic form from circular, rectangular, square, and hexagon kan. It's concrete without reinforcement. Of course, it cannot go very high because slenderness tu akan pecah break. Mungkin low like a footing kan macam rumah kampung kan, ada macam footing kat bawah rumah kampung tu. This can be used macam solid concrete macam ni lah. Stump, they call it stump. Low stump, high stump macam tu. Kalau yang bawah ni pula with reinforcement, seal bar atau rebar ni yang hitam kecil-kecil ni, this one can go very high. This one can go very high, depend whatever side of building and depend on the size and the size of the reinforcement. Okay, this is a concrete fill-up tube with reinforcement. Sorry, the final one says they encase all this I-beam, H-beam, I-beam ni, they encase with concrete. Ni boleh. Kita ada 1-2 slide, we're talking about encasement of the column and beam, which is fire-rated kind of material, can be used to wrap around the raw material, raw form of the I-beam and column. Jadi nampak macam if you finish up, macam nobody knows whether it is RC ke ataupun beam ni steel beam. Okay, let's see I-beam. This is the most important atau common kind of steel used in construction of column and beam. So basically I-beam is shaped as an eye lah, An eye, so the I-beam consists of two horizontal plane known as flange. So atas ni flange, dia panggil flange, term dia flange. Atas bawah ni flange, okay. And then connected by vertical compartment of web of the web, or the web. Ini salah spelling ni. And in this web, this middle here is called the web. So I-beam has tapered edges and gets its name because it looks like a capital letter when you see it in through the cross section. With an I-beam, the height of the cross section is greater than the width of the flange. Height of section ni is greater than the width of the flange. Kalau you're talking about column, normally called the H-beam. Kalau I-beam ni is the web is longer. Because kalau H tu basically equal dimension they use for column. This is the raw material of the I-beam. Dia punya load is more kalau ikut horizontal what they call this beam, I think 3 or 4 times more than the normal cross hollow section. Okay, these some of the detailed sizes of I-beam. This is called width flange kat atas ni, and the webs ni. Fillet ni sometimes some of the I-beam tu the wells ni, the well pun kuat juga Ni some of the sizes. This flange, angle flange, this channel section of the flange. They also use some as a structure juga. Tapi yang ni basically as supporting members lah, buat frame, partition, buat kind of, but not so much for column. Tapi yang ni ada for small like the channel section tu. Yes, we have it a lot of small double story or single story, double story mezzanine floor. They use that kind of material. And this is another size, another section of the ni kan Lintel Beam ni, biasa UB ni panggil. This is bigger, taller. The web is taller than the flange for beam. Because the beam, you know, maybe talking about compression, tension kan, when it's under load kan. So this will just stay there, to take up all those things. And then for column, basically they are like equal. Column, this for column. The flange and so the web is almost equal in height and width. This is some sample the size lah. Size. Ni flange channel pula will be shorter dimension on both bottom and top, and then a longer dimension on the flange. This some of the sample. Okay, let's see what is the type of beams. There are several types of beams which is commonly used in the construction. We see each one of them lah. Cantilever, simply supported, overhang, continuous beam, fixed-ended, they join to the wall, to the side of the column, not to the top. Ni cantilever or simply supported, ni combination of this. This very common one, kita tahu simply supported, continuous, overhang dan cantilever. Ini memang selalu kita dengar lah. Okay, what is simply supported beam? So simply support beam basically is one of those that rests on two to support and is free to move horizontally. I mean, free to move is fixed like in reality structure, because there's some expansion or not kan. So they move. So basically only two support. Okay. This is some of the traditional what you call this structure that we found in UK, Stonehenge, how they fix the column and beam by just a solid material of rock. That give a concept of column and beam structure. And for this two photograph pictures, basically is a typical bridge structure, how they actually join link all the bridges together through many continuous support. Tapi di continuous support, kalau one, in fact, this is so-called bridges They are all independent on their own. Dia tak sambung pun. Because sambung ni hanya this column. So kalau you take one column, two column, they become what they call this simply supported beam. Pasal they doesn't join together. If it is like continuous beam, all this beam will join together independently. Ni satu modul, ni satu continuous beam, ni satu simply supported beam. Semua ni independently. It is not supported. This is another one. Tapi ni is more like a structure, dia combine lah ya. Combine with many column ni, jadi lebih pada continuous beam sikit lah ya. Because of many column, because the length and the size of the building. What's fixed beam? Okay. What is term fixed beam here? So beam is being supported by the side of the structure, of another structure, whether column or wall. Fixed to the side, not on top of it. Fixed by the side. So the beam is like cantilever beam, except that it has no anchor point at the end. It will not move or rotate to the fulcrum of the attachment support. Ini untuk cantilever, dia akan macam ada konsep of moving, dia boleh jatuh macam konsep jatuh. Tapi basically they are all designed to make sure that the beam is in a state of equilibrium. I mean everything is being calculated. Kalau ada force ke bawah, ada force ke atas, dia akan stay kat situ. So the main example of this kind of beam steel and also wood structures. This is some structure. A beam, can be I-beam, it can be just like a truss beam here, from supporting each of the column from one point to the other. It may one span like that. Fixed beam. What's cantilever beam? Okay, this is common in architecture. Lot of architects try to actually express the design feature. Look like building is unsafe because of the way the point of jointing to compared to the size of the building to look very risky. Visually, it looks unsafe visually, but structurally have been calculated in such a way that the suspended structure to have been taken care by the foundation and also the members of such a frame below where the cantilevered beam is attached to. So this type of support is one. This type of support beam is one that has an anchor point at one end only, anchor point. Satu je, in this case is here. Kalau dia like this is not too bad because it goes vertical first, then only spread to horizontal. Normally kalau beam it goes horizontal terus. We got some example of tu. Okay. Yang ni engineer pening sikit lah. Macam ni kan. This is another frame. Kalau you concept, sometimes we see visually like the building is unsafe because it's so huge, but the unsupported area is also quite long. The span of unsupported area is quite long. So the visually look macam is unsafe. For example, for this house here, it look unsafe. But I mean, this is visually, but in reality, structurally, the building is safe because I've been considered about the movement, the turning of the building and whatnot. So this is it's just like more into the visual, like it is something like a sculpture too, tapi this is designed something that is doesn't concur with your visual to say that building is safe. This concept of what's happening kalau it's not properly designed, the building can actually being destroyed or being damaged due to the shear force, due to the miscalculation of the structural component, apa boleh juga berlaku. Ini saja tunjuk what can happen to the cantilever beam. This is kalau you look at airplane, the plane wing also cantilevered because joined to one side. So wing of stationary aircraft as a cantilever beam. There's load on the beam, load particularly inside the beam. Here is a fuel, minyak kat terbang. It's all being stored in the wing. And plus the turbo prop, the engine, the jet engine, that will take the load. A more extreme feature, like the one on top, basically looking at the size, like it really protrude out too far outside. Maybe this is like being anchored behind. It's more like overhang rather than cantilever. But for the stadium feature, that what we showed now, the moment diagram tadi tu, the flow path diagram tadi tu, this is basically is cantilevered because the support only at one point here. Yeah, this is cantilevered. This stadium, it can span because why you cantilevered, because we cannot have column in front here. We disturb hindrance to people to looking at the pitch macam ada barrier tadi. So this is another innovative kind of cantilever beam that has been incorporated in individual house design. Look like something come up from the hill. Visually look unsafe, but interesting by the fact that it is safe. Kalau you tak tahu lah, kalau you happen to pass this highway from jalan to Duta to maybe to the north or to Shah Alam, ada some few houses on top of the hill on the slope. The other concept of this cantilever thing, visually nampak macam takut jatuh, tapi actually it's all been considered in terms of the load factors to the building. Kita kat Malaysia tak banyak sangat, kot tak berani buat kot. Tapi kat overseas banyak. There are a lot of this kind of sample of building, especially dekat slope lah. Okay, what's continuous building? Continuous beam. Continuous is sambung from one point to one point kan. When you have two column or two support, then you call it simply supported beam. Simply supported beam. Kalau you have more column, three more than two, 3, 4, 5, 6, whatever, rows of 10 column, then call it continuous beam. This is the end span, intermediate span. Span actually is a beam for actually from one point to another point. That span. One point, one load point to the other load point is called span. This is some other example, the continuous beam. Whether it's concrete or steel, is the same. This kind of the photograph below basically is about bridge design. We also have the kind of continuous column, but maybe since bridges they column free kan, maybe there's something supporting it below. Mungkin an arc ataupun yang melengkung, arc kind of support kat bawah tu. Overhang beam. There's some similarity of overhang and cantilever. If you most of Malaysian, for that matter, they consider it as cantilever beam. The thing that protrude out, they don't care what's happening behind. So in reality, cantilever is what we show just now. They support from one point saja. They tak ada nothing to counterbalance from the back. In this case, it is like overhang beam. There is some kind of counterbalance element at the back. That means this beam is being tied to the support behind, kan, to feel the support behind. And then it will be more stronger. The reaction here is very strong. They keep it stabilized because of the anchoring kat sini. Because of the anchoring. So it's a beam is stand beyond the wall support. Yes, overhang of the beam is a unsupported portion of the beam. It may be one side or both sides. This is unsupported overhang portion. This is called overhang beam. The other single support. Single-sided or double-sided. So single overhang beam basically beam really supported at 2 points, having one end extending beyond the other support. As shown in the drawing in the diagram here. Whereas where are the use of overhanging beam? This is, some people call it cantilever, some people call it overhang. So overhanging beam is used where it is not practical to provide support to the beam at the end, at one end. Inilah, mungkin tak possible nak buat support sini. Kita gantung lah. Gantung maksudnya cantilever lah. Dia overhang kan dia. Macam ni exactly. Maknanya kalau nak be safe, you have to have this beam here. Tapi, visually nampak macam tak safe, but safe. But it's more like a design feature lah. Especially when you have a house protruding from the slope of here. Dia nampak dia macam outstanding sikit. The single overhang beam basically beam freely support tadi. Okay. And what are the use of overhang beam? So overhang beam basically is used where it is not practical to provide support at the end of the maksud jadi ini tak ada support. Here it's too steep. Too steep. support. So the beam is therefore supported at the location as close to the end of the as possible, and the rest of the beam is allowed to overhang, because became a cantilever in technical jargon. So kalau overhang dia biasa cantilever is technical, that is overhang beam, sorry. They also double overhang, as I mentioned just now. You can have it on both ends, at both ends. So kalau mention here, beam 3D supported at 2 point and having both ends extended beyond this support. Kalau dia macam ni balance, okay lah, building also instead of balance. Some may have a bit, the left is longer, the right is a bit shorter, pada juga. Overhang position basically where the load support tu, and then beyond that is overhang. Some example yang on the right here is crane gantry, crane. They used to crane to move around for some kind of a casting yard, for example like IBS inside the building system, especially when they use a lot of big panels, wall panels of soil, and then they need the gantry to move side left or sideways to actually handle the casting of the so big wall. Casting is you pour concrete and let it dry and cured from wet to something solid, cast. What's castellated beam? This is also another feature. Beam yang it happen to have a lot of openings in between. Of course, the web is a bit longer, but the fact this is more on saving cost of using this beam. Okay, dia belum lubang. This is some example I can show you. Save because of the less material use, and the so-called structural analysis is the same. Structural aspect of supporting building is the same. Of course, the web is one web longer, then give more strength to the beam structure. But this also allow this also allow for some services that come through this on above near ceiling. Then you can go through this opening. Services masuk pipe semua masuk dalam tu insyaAllah. So whatever below will be clear lah. So you got a higher headroom for the maybe parking area or for other floors that we use. Okay, this castellated. Okay, basically this is we have gone a bit on the beam tadi. Sekarang we look at column lah. Since we are on steel, basically kalau if this column, basically we use I-beam or H-beam. H-beam digunakan untuk column, I-beam guna untuk beam, untuk horizontal beam. So column basically is a pillar in a structural engineer. It's a vertical structural element that transmit through compression the weight of the structure above to other structural element below. Termasuklah to the piling. So basically transmission of load from the top to the bottom. Semua tahu semua kan, semua tahu. Tapi nak describe ni mesti you must know how to describe it. And must get the right kind of word term pakai. This is some is made of hollow section. You see the photograph on the left, right here. All this frame, the wall, the column and the beam is all made of hollow section. The hollow. Boleh juga, tak mestinya I-beam ataupun H-beam. Tak mestinya universal beam. Those are called universal beam. Round atau solid hollow and hollow section, bukan solid, also can be used as column and also beam also boleh. There's some other characteristics can use of column, use of steel, tubular steel form to create an image of, say, for example, a tree. This is in the airport, I think, somewhere in airport. And then, of course, all this thing is actually design, depend on your design intention. What you wanted to create the beam, the column. Is it going to be one just simple thin column that goes to the top, atau you create something like V-shaped column? Give a bit of idea on design idea, especially the sloping column. What else? This is some other column, external column. Use beam structures This is somewhere I remember this. Somebody was saying this in Malaysia. Yeah. Kalau you go to Setia Alam, ada glove apa dia panggil, our Malaysian biggest glove company tu, yang dia make billion masa COVID ni. Top glove dia building dekat Setia Alam tu macam ni lah. Dia call high column. High column macam ni. Nampak ke saya? High column macam ni. Tapi tinggi lagi. I think about 7 story punya column atas. Very a lot of column in front of the building. Like a gigantic kind of tree, a coconut tree. So column can be designed many ways, whether it's steel or concrete. But in steel, the casing is important. Casing that case the column tu, you can design whatever ways you want. You can see some of here, macam the first photo tu macam dia tapered, it's tapered from bottom to top. This internal is steel, but the external can be any other material. Okay. This is more elaborate kind of steel column, which part of the so-called design feature. You're passing by, I can't remember where is this actually. This is can be of steel, tapi encased kan with another encased material to make more durable in case of fire or whatnot. These are some of the steel, the last bottom most here. It can be designed such a way that it creates some kind of a pattern that reflect like a palm trees in a rows or not. Maybe kalau kat macam Middle East, yes, it's more structural lah. The bottom tengah middle basically is very simple. Tapi they give idea like some different sizes. Column one size, mungkin the sloping beam another size. Sloping beam. Okay, column is so slender that it will feel under longitudinal load by bending rather than by crushing, and typically having length of 20 or 30 times its diameter. So ni dia panggil, there's some limit the short and long column. This is about the short and long column. Sorry. This is about long column. So long column basically, if the ratio of the refractive length to the least lateral dimension of a column is less than 12, the column is not has to be long column. So basically, kalau you're talking the second paragraph tadi, kalau misalnya for example the column is circular in form, dengan the encase dah siap dengan concrete, dengan I-beam dalam tu, encase is 300 mm sekaki. That means it can go up to 6 meter. 20 times lah of that diameter kan. That means 6 meter height with 300 mm diameter of a column. Once you go above 6 meter tu, mungkin the column can cause bending and then will crush. There is some limitation there lah. Kalau anything that is less than 12 meter, then it's called is short column. Okay, this is a bit of structural analysis on the so-called short column, long column ni. Kalau effectively short column tadi less, long column tu is must be less than 12 meter. 12 dia panggil ratio. Dan tadilah kita kalau talking about, dia ada calculation dapat to engineering. I don't want to get too complicated. Tapi ambil yang simple tadi which is this one, dia calculated macam ni. The second paragraph tadi, basically if you are talking about 300 mm kan diameter, you can go up to 20 to 30 times its diameter size. That's a column. Macam ni lah ni. Ini pun tinggi kan, tapi very slim. Slim. Tapi kita tengok macam Roman column ni memang it's not made of steel. But to give you some idea of the column, it gives certain size that look justified in terms of the size and the element. Kadang ada fluted kan, ada kecil-kecil panggil fluted. Yang line-line ni macam ni fluted. Line-line ni fluted. Dia ada scale dia sendiri. But anyway, for talking about long column, for simple factory like this, mungkin they need a higher space, higher ceiling space. They can still use this long column. Or tall column for that matter lah. We can tall or long column. Okay, anything that is less than 12 tadi macam anything that is less than 20 times then it's called short column. So what happens in structural failure for this so-called short and long column ni? Kalau long column basically with too much load imposed on that long column, then the building will actually buckle. Dia buckle tu. Kalau for short column, dia akan macam ada shear force ni. Ada crush failure kat sini, for short column. So this is another example what happened during the experiment. This is what happened between long and short column. Kalau for short column, this is for long column. Ia jadi bending, buckling. This one, buckle. When you put a load, it buckle. For a short column, you put a load, it will crush, will break. Dia ada crushing point kat sini. Kalau short column, this is some kind of feature of your running a column. Kalau you want to have something big, you want to have something visually look very strong building, but big column, tapi dalam tu is only a small what you call this I-beam je. Boleh buat juga big, tapi you encase it with some material that looks like column, but it's more like cladding, non-load bearing kind of material, but can actually be encased around the I-beam section or H-beam tu to become big column. Visually lah kita nampak very fine, very teeny, very thin kind of macam toothpick kind of column, so not very safe visually. But kalau the design, of course, have taken also consideration lah. So column causes of failure of this column short and long because of this lah. Kalau tinggi dia buckle, kalau rendah dia compress, jadi crush. Short column, this is the ratio effective length to the dimension less than 12 already. Kalau compare macam yang kita bagi simple formula tadi tu, anything that is less than 20 times of ini dah boleh jadi short column. This is short column. You see the black what they call this colored to this diagram. Short column is a continuous beam, short column. Kalau anything macam the one is below here mention tall column, tapi depend on the size and height lah. This is some other column, C column, then be used for this is a short column for whatever building here. Everything but not steel. Yang ni dia have already encase. Tapi bila C column ni mungkin dia encase dalam tu steel, ada I-beam semua kan. Semua boleh encase insyaAllah kalau tak ada masalah. This is on a common talking about strength of a column. This called it column with same length, same height, tapi different surface, different area. Ini column with same slenderness. I mean the tinggi sama, same ratio. Means that this is with this kind of spaces. This is the relevant kind of height for the column. With this kind of surface, this is the relevant kind of height for this kind of column. The size once get bigger here, the surface is bigger, but it's the same. The slenderness ratio tu means that it won't buckle. Kalau the same load overloaded imposed on this two column, it will still buckle. But this is talking about slenderness. Slenderness lagi tirus, lagi risiko buckling. Lagi tebal column tu, and then there won't be so much of buckling on the column. The principle dulu. Okay, this is another aspect of material that we use for column, which for small building like factory, single story, shed, store, whatever tu, we use this hollow section. Even some can be special design, like circular hollow section that can become a feature to the place. What is hollow section? Basically, it is known as structural steel tube and hollow section ataupun hollow structural section, HSS, is a type of steel that is formed into hollow tubular section. Okay, steel hollow section are commonly used in welded frame, column, beam, provided various benefit to a range of construction and mechanical application. So it's the same, it's still the same function, except that it will be less in terms of material, but it's limited in terms of the scale of the building. Sometimes they use this kind of material for decoration purposes, which is non-load bearing to the building. What is RHS, CSS, SSS? Sometimes you baca ni engineering drawing, dia write to the RHS metal steel kan, CHS and SHS. Bagi sikit dia punya ni. The three main type of this kind of hollow section. R7 basically rectangular hollow section. You can see the top most images there. And then RHS basically square hollow section, the medium images. And then CSS circular hollow section. This can also be used as column and beam. Of course, limited to the span. The longer the span, and then the more sagging to the beam. The shorter, then it will be more stabilized on the beam. Okay, external hollow section. And some images for hollow section. Get the way how they join. Yang ni like the force joint sikit. Yang nombor 2 tu. The first image basically, you have to create something like something coming out from the circular section. You only bolt and nut and there. Maybe there's another plate that come out from the hollow section on the surface section. Then they bolt the plate and the beam together. The other one, the last photo basically is a slanting circular kind of beam. It's supporting, I think supporting is the whole facade. The whole facade. Maybe transferred to the ground then. This is for something like it can be decorative, it can be also function as a structural member. The bottom left building, the corridor having all this V-shaped kind of structure. It supported the overhang, the overhang roof and the overhang floor on the top. But you can see the size of the column here is different. It's not like one size only diameter, but you see, once you go up, it gets smaller and narrower. The column. So a lot of ways to design. Depend how you create. I mean, the level of your creativity to actually design with the what they call this, with steel structures. What is lintel? Maybe you have not heard lintel. Tapi some of the writing here, I nampak ada yang tulis lintel over there, Lintol over there. Okay, lintel basically is a beam placed across the opening, like window, doors, etc. In building to support the load for the structure below, structure above. So, if you why do we need this lintel beam? This is basically it can be masonry, or it can be in steel. This is steel, steel lintel beam. So basically, it's to support the opening. For example, if we don't have any of this, and then you have a timber frame door, okay, or window, timber frame door, window. And then all this load on the wall will be the lintel will be supporting all the load from the wall. So if you have a window door here, and then it won't the pressure of the floor and the wall atas ni won't actually affect your steel frame door and window. Kalau without lintel, the weight of this beam above the opening here will be transferred to the frame of the window. The door frame, window frame cannot take the load. They are just to get the frame into size so that it can be easily constructed. The door or window can be easily constructed. So basically, with some of the image here, it has to actually extend out to the wall so that they have support. So this is specifically to protect the door and window below the so-called lintel beam. But if you are in a building or in for example USIM, can see the wall, the door, your studio, you don't see actually lintel, but actually in reality there is a lintel on top of your door. It is to protect the load of the brick to actually pressure on the door frame. Because that door frame to bengkok. So it is a compression member kan. So column is important element every. This is the column defines vertical compression member, which is mentally subjected to the effective length of the axial load. As the load the load along the column, which exceed 3 times for at least in the lateral dimension. So that's how they define column here. Compression member, this column is important element every steel structure. These are used to transfer load to support structure to the foundation ataupun substructure. This function of column. Column tu memang is a must. You have any building that goes up more, I mean, whether single story or many floors. But alternative to column, you have something to design the building without column, then you see what we call it load-bearing wall. And load-bearing wall, basically the whole of the wall, less all the opening, the doors, windows, is taking the load from the above. Of course, they have some limitation. They cannot go sampai di 5-6 tingkat. Sekat 2-3 floor is okay. So you see some of the British building, colonial building, yang government houses, government building tu, most of the design is based on columnless wall, columnless building. They're using the load-bearing wall. So the brick wall tu is a beam that transfer the load to the ground. Ground adalah beam dia ada straight footing dia kan, transfer to the ground. Is some detail of the column, how they're being fixed. When you look at the most this detail, it's the number 2 or number 2. Basically, you have a column called steel plate below the column. Steel plate with opening for the screw, bolt and nut. This is, you see the steel plate. Bawah also there's another nut to stop the plate from actually touching the floor. Actually, the column is floating by the nuts, by the bolt, anchor bolt. There's some space here actually, and then transfer right to the foundation. Ada some detail ni. Yang ni kalau you can use for your design, your design when you draw section drawing, if you are drawing in using structure, that I-beam, this is how you design. Kalau nak put some writing pun boleh juga. You can have some simple specification how actually the steel column being when you cut section being embedded to fix to the foundation. So this is simple and straightforward, and it is very detailed. So remember, kalau you draw section that looks something like this. Whether your plate is above the ground, above slab, ataupun embedded, ataupun this one shallow embedded, so kat dalam ni don't see, only the column will surface from the floor slab. Boleh semua boleh. In fact, I got this video sebenarnya semalam tu on this one, how they fix this column frame semua ni. Tapi video tak boleh buka. I pun lupa dia punya title. Anyway, tak apa, but kalau you want to do your drawing detail section, refer to this detail, so that you do a good design. Ini some other detail which is on the similar concept of column fixed to the base. Base can be a floor slab also. Kalau it is like a rough foundation, basically the floor itself is foundation, so the column can fix on the floor. Rough foundation. Puncher rakit. Okay, this is beam to column. This in elevation view. This is where the beam, yang vertical, remember, is a column. This is a kind of bolt that you bolt across there. You can draw like some like this. This is some just images of beam, how they're being connected together. Yang ni using bolt and nut. We will discuss the detail later on our future lectures. First image, second image, which is bolt and nut. Bawah ni is bolt and nut, but they use gusset plate. This is gusset plate. They all the triangle, the green and the yellow color here is gusset plate. Okay, and the green color is diagonal members of the frame, and the blue is the column, and the orange, soft orange ni macam is the beam. Banyak detail. Kalau you check internet, banyak sangat detail on this one. This is how you draw a plan later on. On your plan, your floor plan of your design, you have to draw something like this. Because we are talking about encase the steel column with concrete. This is concrete. You can see all those symbol concrete yang kecil-kecil, symbol of concrete. This is the beam. The top one is a beam here. This is column. This is how you draw your column. This column is be encased with concrete. So encasement column casing range provide a stylish integrated finish, and is the perfect solution for concealing internal and external structural columns simply, quickly, and cost effective. So they how to do it. But end of the day, you see macam it is a concrete construction, but basically it's steel. This is how it looks from outside. Yang this beam is not encased, but the column be encased. Encased, tutupkan dia. You can also encase with other materials, which are fire-rated material. This is very popular material, Promatech. You can encase it with a material, then it has a fire rated of more about 2 hours fire rated. You have a small frame here. So we encase kan dia create a small frame. The frame tepi ni, drawing kat sini frame ni. C-start they call it, vertical C-start ni. That will actually allow you to fix the external encased material to the column. They pakai C-start ni, screw to the. They cannot screw to the flange. It's too hard. Tak boleh. They screw to the stud. I show you all these threads actually is stud. So this material is fire rated. It's composite material. Ploma, dia punya brand Ploma. Ataupun calcium silicate buat dia kan, piston tu yang tahan fire in case of fire, then it protect the beam, the spray beam from being melted or twisted due to fire. This is another one example which I said here, the example steel structure where beam and column not seen as horizontal and structure and vertical structure. A building or structure can stand by itself by not protruding ataupun not being exposed the kind of normal kind of construction of beam and column. It is a structure, the whole structure is beam and column. Dia macam mixed together. So this is actually is a urban sculpture lah, urban structure dekat New York. By Architect Historic Studio ni. I simpan gambar ni, kita tunjuk juga. They call it the vessel. It dapat award, some engineering award for this one. This is from the award page lah. Ini macam tourist section. It has about 154 flight of stairs and 80 viewing platform. So in fact, the tourists will enjoy this. Kalau you go up and down, you can see like you are intermezing, like going up and down hill, mini hill slope, and then you can it's all you can climb. Tapi tak tahu sama ada escalator tak ada. I haven't seen. One of the students showed me this drawing last time when they were doing some project. This kind of an urban kind of feature that they use for just leisure and for viewing factors lah. Tapi yang weather may not be applicable kot. Kalau sea may expose ataupun can deteriorate very fast. Weather on the western weather, there's seldom raining. Even kalau the rain pun kind of wet material, it's the snow. This is one feature. I got a small video, tak whether it works or not. Oh, boleh. Yeah. Short video je. In fact, there are 2 videos, tapi the other one doesn't work. I need to habis cepat sikit, because I don't feel that.
The process of installing a structural steel frame involves an orchestrated effort of various parts and pieces.
Ya, kena besar sikit tak? How do only 5 minutes left.
The process of installing a structural steel frame involves an orchestrated effort of various parts and pieces, the names of which can be confusing enough, let alone their process of assembly. As we go through the assembly of a conventional steel structure, we're going to identify the nomenclature of the various elements and what those tags represent. A structural steel frame starts with the base, where the columns of the frame attach to the foundation. The columns are attached to the concrete foundation with anchor bolts, which are typically supplied by the steel fabricator for installation by the concrete contractor. These bolts come in various shapes and sizes, and the appropriate one will be identified by the project structural engineer. Because these bolts are embedded in concrete, accuracy of their installation is critical, obviously because they cannot be moved once the concrete is set. If their location is off, that means the rest of the structure is not going to fit together. So to help ensure proper spacing in the foundation, the steel fabricator will also supply setting plates with the anchor bolts. Now, once the anchor bolts are in place and the foundation's cured, the steel erector can begin installation of the superstructure. This process begins with installation of the columns. Columns can be fabricated from two different steel shapes, tube steel and I-beams. Tube steel columns are identified by the following marking, representing shape, physical size, and wall thickness of the material being used. Like hollow structural columns, I-beams start their labeling with a letter, which identifies the beam's shape. The first number indicates its depth in inches, and the last number identifies the beam's weight per lineal foot. Now, regardless of the shape, each column will have a base plate in some form or fashion for attachment to the anchor bolts, and connection points for the upper structural elements. During initial assembly, the columns are loosely attached on the anchor bolts to allow for easier assembly of the horizontal structural elements. The horizontal structural pieces will consist mainly of I-beams. However, in certain areas, tube steel will be used for the horizontal elements. Tube steel is also commonly used for cross-sectional bracing within the framework. Just as with columns, the nomenclature for these pieces is typically the same. In cases where the loads are not that extensive, such as canopies and beams over doorways, a steel channel may be used. Again, during installation, these pieces will all be loose fit until the entire framework is together. Once assembled, the steel erector will go back and begin to plumb all the columns and square up the horizontal sections. As this is done, they will tighten up the connections and install any bolts that were left out during the rough assembly phase. This makes the primary steel ready for assembly of the secondary support elements, which in most cases are bar joists. Bar joists are fabricated in various shapes and sizes, which we will discuss in another video. Each joist is typically tagged, identifying its manufacturer, sizing, and area of placement within the project. As you can imagine, with most projects, there are a lot of different bar joists being used, so knowing where within the project those joists fit make it much easier for the iron workers during installation. They can be installed using either a bolted or welded connection, or a combination of both. As the joists are placed, lateral bracing is installed from joist to joist, which links them together, creating a total system. Now, installation of the bar joist does not complete the framework of the structure. Although the connections have been secured, the frame still has the ability to move out of square. To eliminate this tendency, a corrugated metal deck is installed on top of the horizontal framework. The deck acts in the same manner as sheathing and floor decking does in light frame construction. It provides a medium to unitize the entire framing system, which will help eliminate the potential for lateral movement. At the same time, it creates a support layer for the roofing and flooring. Now, once the deck has been installed, holding the frame in place, the iron workers can then go back and finish tightening and torquing all bolted connections and completing weld joints. This process is called detailing the steel, and this completes the installation of the system. Now, we've only just scratched the surface here of what's involved in structural steel frame construction, But what you have is a good base knowledge that's going to get your mind thinking and start generating questions that are going to increase your knowledge of this type of construction.
Okay, guys, there's a very short kind of video to expose a bit on-site kind of situation of constructing this material of column and beam. So I will actually stop here. Kena letih sikit, tak tahu lah pasal apa. Kalau ada question kita boleh bincang. Anybody ada question boleh kita bincang. Are you there, guys?
Yes.
Okay. I stop sharing. Can discuss. Okay. Heba, how are you?
Oh, hi, sir. Alhamdulillah.
Yes.
Thank you.
Everything okay with you all? How's your design getting on? Please consider whatever you design, when you're designing your floor plan, your section, consider that all the members of structure are steel frame. And I showed you some example in section and plan, how it can be drawn. So make sure that your sketches must show steel frame, and until your finished product later on also is steel frame. Then only the project design and the subject is well integrated. I think it was not stressed in the previous semester because I realized that we don't see any of the details that shows steel frame. The moment you can start on column and beam first, because it's the basic that you do on your plan. Basically, your plan is plan will show the column, and if I-beam, they show the I-beam. If you want to encase with concrete, no problem. If you have some material, there'll be a lot of drawing, a lot of lines to be drawn. So concrete just a single line, they become. But the internal of the concrete column is a steel I-beam. Similar for section, you can do that too. No problem. So this is only a column beam. Later on, we'll do the wall panels. I think and cladding. And then you get more information on detail how to draw your section later on. I really appreciate that you can produce some good section drawing, showing all the detail of the element of steel component inside your section drawing. And it goes up to even roof is more complicated and more delicate because a lot of members to be added on to be drawn as a roof structure. If you use steel trusses, kalau you use the girders like a normal kind of flat roof kind of thing, it won't have that much of detail. But we use this structure, some kind of feature kind of roofing that need a lot, maybe some hanging structure, something like exhaust crystal, maybe you got some cable that's supporting the roof. It's more complicated. But we can also do that throughout our lectures, to give some ideas on how to actually incorporate this steel and draw it in your drawing. The steel member structures, draw it as though the building is already all made of steel. Then the drawing will be different. It's more detailed. Even if you draw out the blow up detail later on, we'll show some of the detail. Block detail, how to make the system of your structure system to workable. I really hope to see a lot of details other than just the roof eave, the foundation, the floor. Maybe some of the panel detail or whatnot. Some of the feature detail, maybe you want to create some kind of feature staircase, maybe. Then we can show some of the design when we come to that topic later on. Okay, are there any other question? I have to drive back to Shalam. There's nobody here, only us, only first year. And it looks like they're enjoying themselves, even though that we have separate studio. We have two studios, but we have problem of communication. We got to have a speaker on one studio. But I think it's manageable, no problem. Okay, guys. Ada masalah? Ada? Any question? Please. So unlike what you see here, unlike concrete, and maybe you have learned concrete before, you want to create a concrete frame, you have to have formwork. Remember, you have to have formwork. Formwork basically made of timber, or as a metal formwork. So you got to erect formwork first, make sure the formwork is in place correctly, and then only you put all the reinforcement, floor reinforcement, corner reinforcement, beam reinforcement, and then only you pour concrete. Okay, until the concrete is being dried and cured, concrete is called cured, for several days. Then only you can remove certain part of the formwork first. Normally they remove the siding first, all the side of the beam of formwork to side of the beam can be removed, but not the bottom one yet. The bottom supporting the slab, you have to remove within 21 days. If it's side formwork, even 7 days you can remove. Now what I was trying to say here, that compared to steel structures, everything being fabricated, cut, or create holes, opening, whatever for fixing, all is done in the factory, like a prefab kind of thing, They cut everything to sizes based on the shop drawing of the engineers. No, shop drawing is prepared by the manufacturer, but the base drawing is prepared by engineers, is checked by the architect. What is shop drawing? You are saying. Drawing. Yeah, there's so many of drawing in architecture drawing, presentation drawing, working drawing, construction drawing, detail drawing, contract drawing. But this one call it shop drawing. So shop drawing, basically shop drawing is a drawing from manufacturer. What I must do is that first architect prepare the architectural drawing plan. Then the engineer, based on architectural drawing plan, they create this engineering drawing, whether structural drawing, mechanical drawing, electrical drawing, based on architect drawing. Okay. When the engineer have done this, they done everything to size, but they pass the drawing to the manufacturer for the fabricating. The manufacturer will draw another drawing based on engineer's drawing. Architect, engineer based on architect drawing, manufacturer will based on engine drawing. They draw another set of drawing. Is a very more detailed drawing, including the thickness, the size, of the angular of cutting the members, and then they pass back to architect and engineer to check. Okay, so engineer check on their part, architect also check on their part, make sure that all the length is perfectly correct. So once they approve, once engineer approve, architect approve, and then the manufacturer can do the cutting, welding, or flexing, whatever members. It basically called short drawing. Short drawing basically prepared by manufacturer based on engineer's architect drawing for the purpose of fabricating the members. In this case, steel structures, the members of the frame, steel column or beam. It's called shop drawing. Not shop drawing like shopping drawings. It's not that. This is whatever that come from manufacturer. It's called a shop drawing. All right, it can be just frame. It can be even type of doors, something that is complicated that the contractor cannot build directly based on the engineers and architect drawing. They got to get manufacturer to prefab, and then manufacturer got to produce the drawing for another counter check. So that is shop drawing to make whole thing very perfect. Imagine it's what we saw is only a simple building. It is like you're talking about Olympic Stadium of China. The bird nest Olympic. You just imagine what kind of drawing you're going to have. With a lot of those. Very not kind of geometric kind of form. Having all this steel frame crisscross over the place. So the big headache for the manufacturer to polish shop drawing. But anyway, all this advanced computer software, no problem can be done. Okay, anything that you all want to ask?
No question.
Yeah. Location?
No question
Wow.
for me.
Where are you? You look like in Bali.
I'm in Kajang.
Oh, in Kajang. Anything you want to ask me? So all this is new to you, isn't it? Because the fact that sometimes you have to be a bit imaginative, about the structure members. But once you see the video, you can imagine, oh, this is the kind of thing they do, the kind of sizes, the kind of details, how been lifted. In fact, there's a video to show what happened at construction site. This morning after the design tadi, I couldn't find the video tu. Macam there's no, tak ada on punya yang triangle tu ya. Banyak kali try tak dapat. So try to trace back, saya tak jumpa kat mana. Because I should have made copy my WhatsApp actually. Alright, siapa lagi yang nak tanya apa-apa? Try to be a bit active later on, no problem. Sekarang ni okay. But we like to, we do not know whether you understand. But the level understanding pun tak tahu juga. We do not know whether how much you understand. Maybe you can understand, but anything you feel like I know a bit, maybe 5%, 10%. And then you recall balik. And then I can probably go over and when we can discuss on that thing. It doesn't matter. The more you go over and over, the more you remember. Okay, macam kata lintel. Satu lagi on column, but this is more on. Lupa nak mention. Alamak. But it don't take structure, but it's more holding the wall. Oh dear, I forgot the term. If the wall is large, is the span of from the column like say 15 meters, and then in between there's no column. Then there's got to put up a brick wall. Okay, now remember the word. The word stiffener. Okay, that brick wall is so huge. If you don't put a stiffener in between, stiffener is a mini column. They put in between brick to hold the brick together to take care of the lateral load of the wind. Sometimes if the wind force is so high, without stiffener, the wall can collapse. There are cases factory with such a very, not only long span, but also very high. There's no intermediate beam. The wall collapsed because of this lateral load. So in order to protect the wall from collapse, we insert what they call this stiffener. They can be steel stiffener or what they call this concrete stiffener. Tu boleh buat macam tu Nanti tengoklah macam mana kalau ni tengok some sample nanti tunjuk on stiffener. Similar to this lintel basically to protect the frame of the door. If without lintel, over years your door cannot be open because why there is some kind of deflection on the wall on top of the door. Once the load been pressed on the door frame, and then door frame deflect, and then the door cannot be open or closed. Macam tu lah That's why that we need lintel. Lintel to protect whatever load on top of the door, so that they can protect the door frame from being deflected. Alright, faham Okay guys, kalau tak ada apa, saya pun nak balik salam. Nak rest sikit. I'll see you back insyaAllah next week lah Kalau ada apa-apa in between tu, just WhatsApp to me. Then we will, I'll see what we can help you insyaAllah Anything about design pun tak ada masalah You can ask anything about design to me with me, no problem. Structure and design, no problem Kalau you find that you can this form be constructed of steel? You can ask me. Hantar sketches, you send your sketches. You can ask me, Haji, can this form be constructed of steel? Some kind of maybe organic form which you find it steel is very stiff, very rigid. They may not be able to do it. But previously we have shown some of the slides where even organic form can be constructed of steel. Alright, Okay, I think we stop here first InsyaAllah kita jumpa lagi next week Kalau apa just WhatsApp me. Alright, thank you everybody.
Thank you.
Alright, I hope you understand my already concerns that I have to create the slide in such a way that it can be easily understood.
InsyaAllah.
Okay, Heba, I'll see you next week. I see you just on online but I didn't see everybody face to face. But I'm enjoying with my first now to face with them. But even that also with the mask I can't recognize them. The next week they come with different dress, I don't recognize them already. Alright guys, I'll see you insyaAllah Thank you. Assalamualaikum.
Assalamualaikum Haji.
Alright. Okay, Harifah.